Hi guys, I'm back. I'm going to explain to you how you're going to use the algebra tiles. So I'm going to start with that little yellow tile here. And if you take a ruler and measure out that yellow algebra tile, you'll find out that this algebra tile is exactly 1 centimeter in length and 1 centimeter in width. So, one by one, if we want to calculate the area, 1 times 1 gives us 1. So this little yellow tile is always going to represent 1. Just 1. Now we also have these little red tiles. And the reason that they're all red is because they all have the same function. Because they are all representing negatives. In this case, the little red tile is a -1. When we're looking at our green tiles and we compare them to our yellow ones, we'll find out that one of the side lengths here is exactly the same length as our yellow one. And we already know that this has a side length of 1. This one I'm not going to measure because this side length here is going to be our unknown. That's going to be our variable. I'm going to call it x in this case. So all those green tiles are going to represent a variable, in this case x, but it could also just as well represent a, or it could represent k. It doesn't matter, okay? Or any other variable, or any other variable. So whatever the variable in your equation is, you're going to use this green tile to represent it. The red tile, you might guess already, is going to represent -x, because we said the green ones are the positives. The red is always negative. No matter what color the front is, the red always means negative. Then we're going to look at the blue ones. Now this blue square has a side length, as you can see here. This side length of our green one was x. So I'm going to call this side length x as well. So this here is x as well. Let's check for the other side. And you might have guessed, I said already it's a square. It's also x. So this is also x. And we know x times x gives us x squared. So our blue tiles here are going to represent our x squared, if there are any in our equation or in our expression. And you might guess the red one is going to represent -x squared. And now we still have those pink ones. The pink ones. Now the pink ones also have a short side that is exactly 1. So this here is also 1. The other side, however, is not equal to x. It's a different size. So we are going to call this in this case y, But as I said, it really could be any variable. And the reason we might need them, we might not always need them, but very often in algebra, you will find 2 different variables or even more. We're not going to cater for more, but let's stick to those 2 variables. So if you have 2 variables in your expression or in your equation, which is very common, then you can use the green one representing one variable, in this case, for example, the x, and you can use the pink one to represent the other variable. And you already know that this is going to be negative y. So here we have y here, and we have negative y. And we still have now these purple ones. I'm going to show you down here. I'm going to use that space to show you something else that is super important. So when we look at that purple one, we can see that this purple one, the side length of this purple one is y. And the other side also has a length of y. So this is going to be y times y, which is y squared. So that's our y squared. And you already know the same in red will represent negative y squared. So we have our positives being represented by our colored, and the negatives are always red. No matter which shape, the negatives are always red. And we have that last one here. Now, one thing I want to show you that is very, very important. I'm just going to put these 2 away so that I'm not going to always get into my way with my arm here. So another thing that is very important that I wanted to show you is called the zero term. And that's something very important, and the concept that is sometimes quite difficult to understand. And that's why the algebra tiles are so important, because they make that very, very visual. If you have 1 here, and to this 1, you're adding a negative 1. What do you get? Here it seems obvious. 1 take away 1 is 0. When we look at this on a number line, and we have the 0 here, to this 0, we add a 1, meaning that we're going to move 1 step to the right, ending up at 1 here. And then we're going to add a red 1. Negative means we are moving to the left on the number line. So that's my negative 1 here. I'm moving to the left. And I'm ending up at 0 again. That's where I end up being. So 1 at negative 1 gives us 0. And I'm going to show you one example where this becomes important. And you might think, well, that doesn't make any sense, but you're going to need that later on, and I'm going to revise it then. But I want to show you here because that's why we're talking about, one reason why we're talking about zero terms. So if I have 1 and I add another 1, I end up having 2. Okay? Now, I want to add another 1 to these 2. So I have 2, and I want to add another 1. But I want it to stay the same. I don't want to change the 2. I just want to add another yellow 1 here. And obviously that doesn't work, because now I have got 2 here and 3 here, and there's no way that these 2 are equal. However, if I add a -1 here, I've just added 0. Now, if I add 0 to 2, I add nothing to 2, right? And if I add nothing to 2, then I'm still left with 2. And this is something that becomes quite important in algebra later on, that you can always add 0. You can add the 0 term to an equation at any time. And the same is true for your x. So x take away x is also 0. That's 0. That's another 0 term. Or x squared adding a negative x squared also gives you 0. And that's where I want to finish today. So I wanted to show you that if you have 2 of the same size and shape, one red and the other one, whatever color it is, this is always going to be 0. And 0 we don't usually need. We're just going to chunk that away in our expression. And you're going to see how that works in the next video. Thanks for watching, and I'll be back with our next video shortly.